Good morning, everybody. Thank you for coming back from break and coming to talk with me about a topic that's really dear to my heart, but really not to that of too many other people. And I'm hoping that I can do a little bit to change that. So, as you said, I'm Tabitha. I do a lot of various sorts of things, and that wide range of experience is kind of what has led me to be where I am with regard to seeing vulnerability scanning as something that can really be enjoyed and that a lot of value can be generated out of. But it's not great. If it was great, I wouldn't really need to be here. It's kind of bad. People often really hate vulnerability scanning and see it as a chore, as a thing that really gets in the way, as a thing that's disruptive. And there's an extent to which that's absolutely true. Vulnerability scanning kind of has an impossible job of trying to be intrusive enough to find things while being unintrusive enough to not cause outages. It needs to be broadly ranging enough to actually find all of the various problems in the environment, but also not be saturating you with false positives and false negatives. And it's never going to be able to do all those things perfectly. But the more folks with different backgrounds and different levels of operational engagement that we can have working on it, the better that we can do to get it to overcome those challenges, make the most of its strengths, really get something out of it, and minimize the harm that it can do. Like, it can really be fun and useful. It's fun to get up to shenanigans on the network, send a lot of weird packets, do things that you normally can't get away with, and also useful to make your future life easier. And in the end, it's probably a compliance requirement. If you're going to have to do it anyway, do it in a way that is good, that feels good, and is useful. So really, there's three things that I would like to be able to share with you today to send home with you. I would like to share with you at least why I have fun with vulnerability scanning and the ways that I think that it can still be a thing that you can have fun with too. Give you the background that you need to be able to talk to the folks who are running the vulnerability scanning system, or if you get really excited, start one on your own if you need to. And also just get you kind of in touch with the idea of jiggling the door handles on the network and seeing which doors are left unlocked. So there's going to be 5 kind of key points that we'll go through in order to do that. First, I want to tell you, really what's in this for you, because I think that it's pretty widely thought that there really isn't much in it for you, but clearly I think that's false, and I'm gonna sell it to you as well as I can. Once we've done that, we'll talk about the sort of background information that you need to be able to read and understand individual line item findings on a vulnerability scanner report. With those in the bag, then we can get down to actually validating those findings, because the nature of a vulnerability scanner is that it's prone to false positives and false negatives. So just because something is on a report, that means it's something that you should think about, but it does not necessarily mean it's something that's true. Once you know which of the findings on a particular report are actually things that that are real and true, then you need to be able to evaluate what risk those findings pose to you, because that's very particular to your situation, to the network, to the application, to the systems, to the way that you manage systems. And so taking a one-size-fits-all approach for that is going to turn out badly. But y'all have context as ops people to really power that vulnerability evaluation. And once you've decided that something is a priority to do something about, it's really key to do the right thing about it. And that, I think, is where, if I put on my security hat, where folks like me often fall down, coming to folks like you, like with a long list that says, we got Apache 2.6.18 on these 67 servers, and by next week, boy, you better fix that, or the hackers are gonna come, and they're gonna destroy your house and rename your dog, and it's the wrong, it's just not a good approach. Ops has already got a handle on this, but when there's these kinds of serious findings, that indicates it's an opportunity to tune the processes that are already there and take care of these things as part of the normal operation and maintenance of things. And so that's really important. So we'll get right started. What's in this for you? The two big things that I think are in this for you are you're going to enjoy this and the InfoSec team is going to love you for it. So why are you going to enjoy this? I'll read the slide to you in translation. Vulnerability scanning can help you uncover the servers that time forgot. It can give you a steady stream of excuses to decom old junk that you've really had it in for a long time but never been able to get rid of. It'll help you to reach out to the folks who are doing InfoSec and help them shift away from being the department of no, because that's a common problem, and it's a thing that I really try to focus on when I have my security hat on, is being the department of yes and, yes but. But maybe you deal with security people who are still the department of no, and being able to come to them and say, this is a thing that we're interested in too, let's work on this, could help to transform that relationship a bit. And also, incident response is less fun than being on vacation. And so if you can reduce the amount of time that you spend on incident response, hopefully you spend more time on vacation. And why is the InfoSec team going to love you for it? I mean, first off, they're afraid that you're going to hate them for running their vulnerability scanning system. The whole way that a vulnerability scanning system works is by trying to create unusual conditions on the network, send unusual inputs to things, do things that don't usually happen. And as a security person, that is a really difficult balance for me because of the tension, like I mentioned before, between being intrusive enough to find things and unobtrusive enough that you don't break important things. It is inevitable that things will break from time to time as a result of security scanning activity, and it's really important to make sure that those things happen in a way that is as easily recoverable as possible, that people are aware of, that people are anticipating, to really minimize the pain of it. Another reason that they'll love you for it is that you know what you're running, you know what the applications mean to the business, you know what the servers mean to the applications, and so you can provide a lot of context that security people usually don't have. We spend a lot of time learning about cool ways to knock over systems, cool exploits for things, but to make practical use of them, or on the defensive side, to accurately threat model them, you need to know, what are you going to use those cool exploits for? And we can't all know everything. And so, if people like me are spending a lot of time learning about cool stuff you can get away with, then we really need to lean on you to know, what does that mean within the context of an organization? And the last thing that, that they can really love you for is to help ensure that the remediation planning that they're doing and they're trying to track, which AKA giving more work to ops, can be done in a way that doesn't cause problems. So hopefully that's a lot of good reasons to be involved in vulnerability scanning. So I think the first thing that we need to be able to do that is understand what you're reading when you read a vulnerability scanner report. Vulnerability scanner report is going to talk a lot about different kinds of exploits, so that's where I'll start too, is to talk a little bit about different kinds of exploits. My educational background is in math and physics and critical theory, so I recognize that I am not qualified to produce a rigid definition of exploit that will cover every possible circumstance. But in general, it just means performing some kind of action on the system in order to change the state of the system in a way that was not anticipated. So in my opinion, most exploits will fall into one of these kind of categories. The most exciting and news-generating types are remote code execution exploits. So Eternal Blue is a really well-known recent Microsoft vulnerability where if you send certain magic packets to an old RDP port, ta-da, you can execute machine code instructions in kernel mode. Props to Kevin Beaumont, Gossie the dog, for forcing a name onto that vulnerability. This whole thing with named vulnerabilities is kind of strange to begin with, but generally they're going to get named by the people who are discovering them, and he totally didn't. He was just sick of remembering the MS-19 number for it and posted on Twitter one day, hey everybody, I'm naming this vulnerability Bluekeep, and we're just going to roll with that, right? And now if you look, all of the security press and vendors are actually calling it by that name, which I think is kind of funny. Another very common category of exploits is authorization or authentication bypass exploits, where by doing something funny, you're able to do something that is a feature of the software, but which should not be available to you. So, reading a file you shouldn't be able to read, pulling data out of a database you shouldn't be able to, submitting web application requests under the identity of another user, those sorts of things. Or in other words, I can do something inappropriately. Third category, information disclosure. The OpenSSL vulnerability that got a lot of press a couple of years ago, Heartbleed, is one of these kinds of vulnerabilities. And like with Heartbleed, if you sent a series of magic packets to an OpenSSL server, it would cough up 64 random kilobytes of memory. And then you repeat that and repeat that and repeat that and sift through that trash, and eventually you find really interesting things like the private RSA key of the server cert or passwords that are in flight in the application or whatever. But the point is, I can learn something inappropriately. And then sort of the least exciting, but depending on the operational impact of it in your environment, denial of service attacks. Like recently, a Linux kernel vulnerability was being called SAC panic, where if there was a reference counter in the kernel for the number of outstanding selective ACK packets, and the developer expected that there was some extremely large number that should never be reached in practice, and if you tried really hard, you could reach that, and that would cause it to bug check, and that's unfortunate if your application was running on that server. So I can disrupt you inappropriately. I haven't really seen a good, rigorous academic classification system for exploits, but there is the common attack pattern enumeration and classification system, and there's the common weakness enumeration system, which both kind of approach this same topic from a different direction. I think in the KPAC, there's 300 types of attack patterns. Well, here, if we're going to try and oversimplify down to 4. So those are exploits. So what do we actually see in the output from a vulnerability scanner? Typically, you're going to have a bunch of discrete items of data. Usually, they're going to have some kind of name for the vulnerability, what the host is on which the supposed vulnerability was discovered. Typically, vulnerabilities are associated with a network port, a TCP or UDP port number. There's a common vulnerability scoring system, score, that gets calculated for a vulnerability. Usually there will be a series of other references to vendor advisories, blog posts, other background information to help you understand the supposed vulnerability. And usually the vendor will summarize what they think the impact of the vulnerability is in somebody's environment. And that can be really helpful so long as you use that information to decide how much the environment they're talking about is like your environment. A note about CVSS scores. There are 2 versions of CVSS commonly in use, CVSS version 2, version 2, and version 3. And people in the security space get kind of excited from time to time talking about the exact details of was this calculation done appropriately for a certain vulnerability? Should it have been recalculated in light of later research on similar subjects and so on? But I'm going to say it's like any other kind of metric. It can indicate to you that you should look at something, but it's not a measurement. You can't do math on it. You can't at a glance know that something is more important than something else because it has a higher or lower CVSS score. So it is an item of information that you can use to choose what to pay attention to if you don't have another clear way of choosing, but it's not worth putting a ton of faith in. So here's a screenshot from a common vulnerability scanner, NExpose, and we can see here, I don't know, I can't make it bigger or better looking, so unfortunately you'll just have to take my word for it. But it's got all of these things on here. We've got up here the address of the host that was scanned, some information like its platform, and a list of supposed vulnerabilities that have been discovered on this host. Let's see if this is any more readable. All right, it still isn't. But within this, now we're looking at a particular vulnerability, bind, buffer overflow in network code. And you've got on here, you've got the CVSS score somewhere. You've got the host that it was discovered on, the port it was, links to further information, and a description here. Off by one error in the network fetch feature, blah, blah, blah. Here's a very similar screenshot from OpenVAS, which is an open source vulnerability management system that I happen to be a fan of. And as you can vaguely see, it's the same information presented in a different kind of tabular format. But still, you've got a list of vulnerabilities that are supposedly discovered on various hosts, the IP addresses of those hosts, what the vulnerability is, how severe the vulnerability is believed to be, and you can click through to get more information about a particular vulnerability with links to vendor write-ups and so on. And here's the same thing in Nessus, and again, it's the same information organized in a slightly different way. We've got here it's organized by application, so it thinks that there are 13 various issues with PHP as installed on this host, Windows various issues, because these are all scan results from a lab environment that I stood up with a lot of intentionally very vulnerable machines in order to make the results look interesting. Then you can click through onto a particular vulnerability result and, again, see explanation of what the vulnerability is supposed to be, more background information, where to look it up. So now that we have read what's in one of these reports, we're going to go through the supposed findings in the reports and decide whether they actually apply to us or we need to do anything about them. And to do that, we need to understand the procedure that a vulnerability scanner works, because that helps us to understand why it's so prone to false negatives and false positives. And then you need to think for each result, am I vulnerable and does it matter in my environment? So a vulnerability scanner is going to basically follow a loop like this. You define a target series of hosts or network ranges, and it will, within that target, enumerate services that are running on the network, talk to them, try to determine what service is running on each port, what versions of services. Once a service has been identified, then it can go through a database of various vulnerabilities and sometimes match those up based on identified version numbers. Sometimes it can actually execute harmless exploits against the service where, like in the case of the MS17010 Eternal Blue exploit, you send a series of magic packets to the SMB port, and if you do it just right, ta-da, kernel mode code execution, but you can also send a certain other series of magic packets such that it returns one error message in the pre-patched state and a different error message in the post-patched state. And so in a very real sense, you're exploiting that vulnerability, but not in a way that offers any risk to the host and in a way that makes you really sure that that particular service is vulnerable. And so that kind of gets into how you can get so many false positives and false negatives, because if the test is written in a way that's kind of fast and loose and says, I pulled a version string, the version said foo is less than bar, therefore you're vulnerable, then your vulnerability scanning system may not be aware that in enterprise Linux distribution, blah, they have backported the fixes for that. And so, yeah, I'm running Apache 2.4.18, but this vulnerability that came out in 2.4.36 is fine because the vendor backported it from 36 to their particular branch of 18. Alternately, it also means that you can get false negatives because a service has some vulnerability, but the scanner was unable to identify the service and is therefore unable to warn you about the vulnerability in it. And that's why these reports can be so valuable, but you need to interpret them. So that's why you need to think about, am I actually vulnerable? Because sometimes tests will misidentify the service and tell you that your Apache server is vulnerable to an IIS exploit, or your WordPress instance is vulnerable to a Drupal exploit or whatever, and you know what the application is, so it's very easy to look at that and say, you know, certainly this can't be. The tests could have bugs as well. You know, the tests themselves are little computer programs, and they aren't always perfect. And, you know, as I mentioned before, backported fixes. This is especially a thing in enterprise Linux distributions where the whole purpose of the vendor is to backport fixes for you, but the vulnerability scanner doesn't necessarily know about them. Even if the vulnerability does exist in your environment, it may not be exploitable. A lot of applications are very large and have very large attack surfaces. PHP is a great example of this. It comes with so many modules out of the box, and over the last 5 years or so, a lot of the really bad vulnerabilities that we've been seeing coming out for PHP are in optional modules that may not be used by any of your applications. And so it may very well be that you have the vulnerable code sitting there on disk, doing nothing and inaccessible to attackers. And if that's the case, then probably you want to get on patching it anyway, but you don't need to have your hair on fire about patching it. And that's a thing that you need to have a lot of context around your application and around your services to be able to decide. You know, in other cases, configuration. You know, a server may have a feature that is dangerous, and you have that feature turned off, and you can read about a particular vulnerability, learn how to exploit that vulnerability, try it, see that it doesn't work, and then feel confident that, yeah, I really have that feature turned off, and I'm okay. Which, again, isn't a reason not to patch, but it's a reason to calm down and let your normal patching procedure take care of it. And furthermore, you may have compensating controls that reduce the severity of an issue by making it harder to exploit. You know, you may have a good web application firewall in front of a web application that has a SQL injection vulnerability. So if the user could send a malicious input string into a certain form, ta-da, they could do queries against your database, but you have this opinionated proxy sitting in front of it that is probably going to stop them from doing that. And again, that isn't perfect, so you need to get on fixing that, but that control could give you some extra feeling of safety and flexibility that you can fix it on a different time frame than if it was sitting on the internet waiting for a worm to take care of it for you. After you've validated the findings, you understand what they're saying and what they mean in your particular environment, you need to be able to evaluate the risk of those real vulnerabilities that you found and how those vulnerabilities could be used against you. And again, that depends a lot on your environment and the data. So I think there's really an important thing to understand about this, which is we'll talk about the attacker life cycle. We'll talk about, you know, if I'm going to put on my attacker side hat for a little bit, what I'm going to do when I'm looking at a system and I want to bust into it and achieve some kind of goal, because that is the understanding that you need to be able to evaluate how useful a particular vulnerability could be to someone who is trying to get up to no good. So it's essentially a big loop that kind of looks like this. This is a general problem-solving algorithm that's applicable to almost any aspect of your life. It's talked about in a lot of different contexts with a lot of different names, and the details are slightly different everywhere. The Lockheed Martin Corporation cyber kill chain is a thing that you can search for, and you'll see the diagram that I'm about to show you, except completely different and with a lot of military terminology in it. Folks from the military may be familiar with the OODA loop, observe, orient, decide, act. There's a million ways to describe this workflow, but it's quite general. So to work through this just as an example, if I'm playing information security capture the flag game and I want to solve a particular challenge, I'm going to begin by, not necessarily on paper, but if you're just getting started thinking this way, it might be helpful. Enumerate everything that I know about the target, which at the very beginning may just be an IP address. Then, based on everything that you know, think of each next action that you could take based on one of those bits of information. Once you can consider all of your possible next actions, choose the one that is most likely to get you slightly closer to your goal. Take that action, learn something from it, and recycle the loop. And so study, plan, study, plan, study, plan, attack something. So, in the case of a CTF challenge to root a vulnerable server, I may only have an IP address. So the first thing I'm likely to do is run a port scanner against it, learn what services it's running, learn what versions those services are. If there's now there's a lot more that I know. Now so I've gone from study to plan. Now I'm in the planning stage. I'm going to look at all of those services, and for each one, think about what does that tell me about the host. If I see that it is listening on port 445 and identifies itself as being Windows, then I know that it's likely to be a Windows server, and I can start to think about looking for certain known vulnerabilities that may be able to just get me in, because don't ever assume that you're going to be lucky, but don't discount the possibility that you might be lucky either. So based on that first information, think about quick wins. Then go back to the study step. Oh, this looks like it might be a Windows server. Okay, let's do some more Windows-specific enumeration techniques to learn more about it in order to plan other things that I might do. Finally, I think that I see that, some certain port is running some service with a well-known exploit that I can get from the internet and run. So now I'm going to be back into the planning stage and make sure that I know how to run that program that exploits that thing. And maybe that might mean standing up a VM on my own laptop, running the same version of the software and trying it, making sure that I can really succeed. Once I think I know what I'm doing, then I've gotten a good plan, and I'm going to proceed to attack something. Run that exploit against that host that I believe is vulnerable. If I'm lucky, then maybe I do succeed in gaining access to a host, and if being on that host is my only goal, then congratulations to me, I've won the game. Maybe the exploit fails, and now I've learned something, and I'm back to study. Or maybe I do gain access to a host, or I increase my privilege level in an application or something, and it doesn't actually help me. It isn't my goal, but it gets me a little closer to my goal. And in that case, I may want to take some action, plant a piece of malware on that host so that I can come back and access it easier later if I decide that it's part of the way to get me to my goal. So then I'd be persist, and then cycle back to study. Now that I have this spot of persistence, what can I do to get closer to my goal? And we just iterate on this flowchart until we win or give up. So to get more into this, I really recommend the book Penetration Testing: A Hands-On Introduction to Hacking, which is just essentially problem solving with a lot of neat tech in it. So it's a good read by a good author. And it can really help with understanding the meanings of these types of vulnerabilities within your particular environment. So if that's what we want to do as attackers, then as a defender, that's what you're up against. And so you have to ask yourself, what am I protecting? What could someone want? And these are some examples of things that someone could want. You know, someone could want simply to harm the business by causing an outage of something important. Somebody could want to steal your data. Perhaps you're a manufacturing firm. You know, espionage. Someone could want to steal plans for a new product. Someone could be interested in targeting your customers. Perhaps you're a large email provider and you have a lot of clients who are doing important things in the world that have made them enemies. That can make you a target as well. You know, somebody may simply have it out for you and want to embarrass you. Or they may just want free Bitcoins. And you left your Kubernetes control plane open to the internet with no authentication, and they plunked down some pods mining Monero. It's a thing that happens, and it's a thing that somebody could want. So based on the ideas of what you have that someone could want, then that gives you a context that you can place a particular vulnerability into, to think about how could this vulnerability make my attacker's life easier? Because that's what you want to prevent. You know, as a defender, your goal is to take advantages away from your attackers. And so imagine who may wish to perform harm against you, why they would want to do that, and brainstorm ways that they would perform that harm against you. And within those ways that they would perform harm against you, how could this vulnerability on this service aid them in their goal? So I'm a big fan of Adam Shostak's book, Threat Modeling, Designing for Security. It's really accessible. There's a great card game that goes along with it, which is really educational and actually a lot of fun. And there's a concept of attack trees, which almost 20 years ago now, Bruce Schneier wrote a great blog post about. Once I have the slides up on the internet, these are all hyperlinks. But in the meantime, if you just type attack trees into Google, like the first result is going to be his blog post. So I've drawn a couple of example attack trees because within the context of evaluating the risk of a vulnerability, you're kind of using attack trees backwards. And so somebody that's actually in the governance, security, and compliance team probably has a huge library of attack trees to help them to understand their risk exposure for various services. But we kind of want to use them backwards. So we want to very quickly imagine partial attack trees where our vulnerability appears as a node somewhere in the tree. So like in this case, you know, your attacker's goal is to steal engineering data. You know, 3 ways that I just thought of off the cuff that they could do that. They could try to steal paper records out of an office, and we're not going to discuss that any further. They could try to reverse engineer your existing products. We're not going to discuss that any further either. Other people have to worry about those things, but those aren't our concerns. They could try to exfiltrate digital records, though, and that could be part of our concern. So one way that they could do that would be by copying files from a file server. Well, to do that, they're going to need to gain access to a file server. To do that, there's going to be various things standing in the way of them gaining access to the file server. And so, you know, one way that we could place a remote code execution vulnerability on a public web server into context would be, if I can pop a web server, then I can establish persistence on that web server and start using it to attack the rest of your infrastructure. Scan around on the things that that web server can access on the network, find something else that I can pop, pivot off of that web server and into the inside network, find a file server, start copying the files out of it, and go home because I won the game. There are many other ways that they could steal engineering data, but that's a way that that remote code execution exploit against your public web server could help them to. You know, popping that web server doesn't give them your sensitive engineering data, but it gives them assistance on that part of their journey, and therefore we wish to deny them that assistance. You know, another thing could be, suppose they want to infiltrate your customer's network. An authorization bypass in a software lifecycle management portal that you have could help them to do that in a way that you can imagine here. Another common thing that people are wanting to do right now, because it is not particularly profitable but is extremely low risk, is gain access to your cloud resources so that they can burn your credit card mining Monero instead of their own. And username disclosure in a custom web service does not immediately lead to that, but it can enable various branches on an attack tree, such as this one, that ultimately leads to them being able to do that. And so, like on this particular attack tree, I would say that helping to ensure that your system, that ops people don't commit creds to a public repo is more important than getting rid of the username disclosure vulnerability in your web service, but that's what prioritization means. And if you have taken care of the higher priority issues, then you're going to get some value out of making it harder to use your service to get usernames, because you need usernames to guess passwords. And, some people are just want to watch the world burn. And they may only be in it for the lulz. And there's a lot of ways to achieve lulz when you have no sense of decency. And one of them could be to block your users out of your service just because they think that's funny. Well, here's some ways that they could do that. Depending on the size of your organization and who your hosting provider is, you may be a much softer target than your hosting provider, so we're going to assume that they're not going to find a way to DOS all of Google Cloud, but perhaps they can find a performance bug in a custom application that you have, and by banging on that performance bug, they can make your application so slow that users get angry and go away, and then they laugh their evil laugh. So by patching that performance bug, you can deny them that pleasure. So with this kind of thought about attacker lifecycle and about the sorts of things that attackers want, then you can have an idea in your mind of which ones of these results on this report are the most pressing, down to which ones are nice rainy day projects, and you can start to plan how to remediate them the right way. And basically, you're going to patch a bug, you're going to mitigate a risk somehow, or accept that the risk is inevitable. Hint, you don't want to accept that the risk is inevitable. It's better to just let things be on a rainy day list. So for patching, we're all doing patching. And so when we see vulnerability scan results that say, oh, this thing is old, how come you didn't take care of it? I don't see that as proof that we don't know how to do our jobs, but as proof that something slipped up in our procedures. Because I think we can all agree that ideally everything would be up to date and safe all the time as a result of the natural actions that we take every day. And so when something is stinky and old and embarrassing, it's because something went wrong. And so that's a really key place where I think that, I'm going to put on my ops hat, where we can, I'm going to put on my security hat, help to interface better with security people by showing that we have systems in place here, and when these things, when things slip by, that's a sign that there's something to improve, and that we're into that, that we're happy to learn about ways to improve our processes. And that's a big quality of life win for us too, because taking care of things outside of the normal process is time consuming, and it's miserable, and it's bailing water out of the boat while there's still a hole in it. So a lot of times with appropriate planning, you can remediate these kinds of problems without going outside of the normal flow of things, but instead changing the procedure and then letting the now improved procedure run its course. Next thing that you can do, sometimes there are issues that aren't patchable. There are issues of, this is a valid configuration that happens to be a bad idea, and it's unfortunate that it is a valid configuration, but it is, and we're using it. And sometimes you don't really need it, and you can just go and turn that thing off and then be happy. But sometimes you can't. Sometimes that feature is risky and potentially harmful and necessary for the business. So in that case, having somebody breathing down your neck to create a deadline to change it without context about what that change entails can be really hurtful. You know, it can really be a drag on the relationship between ops and security. And so that is another thing that is a common pitfall that can be avoided by having those of us who are doing system maintenance involved, because we can say, thanks for sharing how scary that is, and we're going to need to start an engineering investigation into how we can stop being dependent on this scary, dangerous feature. And by having that communication loop closed to say, thanks, we know about it, and these are the steps that we're taking to learn how to stop being vulnerable to it, then that can give everybody a sense of safety. And the security folks, since they now know that you can't just fix it, they can instead offer ways that you can monitor for it. So during the time that you are vulnerable, you can at least know whether somebody has hurt you with it or not. So, you know, you may be able to put some more network controls on something with additional firewall rules or with additional monitoring so that you at least know that you're safe. And that takes time and that takes planning. And so being involved with the security folks so that you are part of that planning is really key, you know. Or you can say, yep, that's how it's just going to be. And once you get down to vulnerabilities of a low enough severity, then you do end up doing that, because vulnerability scanners will often show things like TCP timestamps. I think I can guess the uptime of the system by looking at TCP timestamps. Well, it's not Windows 98 anymore. You probably can't. And so sometimes you look at a result and say, that's technically true, but it doesn't actually hurt us. So, in conclusion, vulnerability management needs help. We are people who can help, and it's fun. You know, it's an excuse to send weird packets on the network. It's an excuse to learn new, interesting tech things that we didn't already know, and it makes the rest of our lives easier. So, thanks a lot for coming. I hope you can go back and get involved.